Hey, small little introduction. When I decided to make videos for this year as a little walkthrough, it was more just for like a couple friends that I wanted to kind of get to do Advent of Code. And I've been really surprised with how many people this has helped, like the nice comments. So I just want to say thank you for that. I know it's nothing like crazy, but I'm really happy to hear that like some people have had gotten like some use out of this. So yeah, thank you for that. And also, I might not be able to upload these like immediately because it is my finals week, and I've been a little bit busy with that, so I apologize, but I will try to get the video out before the next day, hopefully. So yeah, without any further ado, so day four is actually a pretty straightforward, easy one. Um, if you go ahead and look at the question itself, so what it's asking you to do is, for the first part, after you parse through all of it, you're basically seeing how many numbers on this left side match how many numbers on the right side. And then um, so if you have one match, it's 1 point. If you have two matches, it's 2 point. If you have three matches, it's 4 point, 8 points, so forth. So let's go ahead and start coding this. So what we're going to do here is we're going to just create a function. And once again, I've already solved this. So um, it's going to be a little bit like, oh, real convenient that everything lines up nicely for part two. But yeah, so we're going to create a function called matches. And what this matches should do is given a line, so given like a line like this, it should tell me how many matches there are on the left side and the right side. So this is more or less just parsing. First of all, let's just get this code out of the way. So for L in input.split lines, print L, let's just sanity check. Here you can see this is the test case. So now we'll just go ahead and call matches on L for this for now. And let's call this. So inside of this, I have a line looking like, here, let me copy it over. All right, we have a line like this. So what we can do to parse this is, first of all, I want to get rid of this little left side here because I'm assuming I don't need this information. So what I can do is I can call L.split, and I'll split it on this semicolon, or this colon here. And then I'll throw away, basically, since I always know this is going to return me two things, it's going to return me the left and the right side, I can unpack these into variables and just throw away the first variable. So now if I go ahead and just print this out, I can show you, we're just discarding the entire left side. And we do end up with a leading space, but that's okay. And then now we'll just go ahead and create a left-hand side and a right-hand side, and we'll get that by splitting on this little vertical bar here. And if I print out just my left-hand side, we'll see we get this. And then finally, if I just call split on this, you can see it gives us a list with all of these little things as strings. Normally, this might be a little bit of a problem because we want it to be an integer, but since we're just checking if they're matches, it's fine if they're strings, because a string 17 will match a string 17 just fine. So now, since we want to see how many are matching with each other, sets are a great use for this. So if I turn my left-hand side into a set by doing LHS, and I want to give it LHS.split, then I can do the intersection, which is basically all the elements that are in both sets. So we'll do this with right-hand side split. And if I print this out, you can see we end up getting all of the elements that are both in left-hand side and right-hand side after we split both of them. And this is all of the matches we have. And finally, we just want to find out how many matches we have. So we'll go ahead and return the length of this. And now, so if we look at part one, they want us to basically go through each card and score how many they are. And the score that we have is 0 if there's no matches, 1 if there's one match, 2 if there's two matches, 3 if there's two matches, or, sorry, 8 if there's three matches, and like so forth. And if you notice, this actually ends up modeling the math function. If I go dismos.com search, okay, whatever, we end up getting a nice little function like this. And you can see here, if we get here, if we get 0, we'll just like ignore the offset. But if we have this, we have one match. At the next x value, we get two matches. The next value, we get four matches. The next value, we get 8 matches. The whole reason why is this is basically saying for every x, multiply by 2 again. And then since we want this to be at 1, it should give us a score of 1. Let's go ahead and subtract 1. So I'm going to exponent here. So we'll do x minus 1 here. And then now, At 1, we get 1 point. At 2, we get 2 points. At 3, we get 4 points. At 4, we get 8 points, and so forth. So this is a nice little math function we're going to use. And this is going to give us our score. The only problem here is when we get 0 points, or 0 matches, we should get 0 points. But this math function is going to give us 0.5. So a nice little trick we can do is we can just turn this into an integer, which will round this one down automatically. So now, if we want to go ahead and get the score, we can just go, first of all, create a variable to save it. So, oops, p1 is equal to 0. And let's return this p1. And so we'll do num matches is equal to this. We'll do p1 plus equals 2 to the power, this is how we do power in Python, to the power of num matches minus 1. And then finally, let's turn all of this into an integer so we get the little round down. If we run this, we get 13. If I look here, we get 13 points. And if I run it on my actual input, we get 21558. 21558, perfect. So now for part 2, instead what they want you to do, it's a little bit complicated, but if you just look at the example, it makes a little bit more sense. You start off with every card, and then for example with card 1, if I get 4 matches, I get an extra copy of the next 4 cards. And then we get card 2. On card 2, we have 2 matches, so we get an extra copy of the next 2 cards. And we do this for every card 2 we have. So it's a little kind of, I wonder if I can do this as like a little visualization. Let me go ahead and just modify my actual input. All right. So if I go ahead here and I'll kind of just put these like next to it. So I start with 1 of each card, like this. Here we get 4 matches. So for the next 4 cards, I'm going to get an extra copy because I have 1 card here. Now for the second card, we get 2 matches. So I get an extra 2 copies of the next 2 cards. Here for card 3, we get an extra, if I look here, we have 4 instances of card 3 by now. That checks out with us doing it by hand. And then we have 2 matching numbers, so we get 4 copies of the next 2 cards because we already have 4 of card 3. So we get 8 here, and we get 6 here. And then we have card 4. We have 8 instances of card 4, and it has 1 matching number. And since we have 1 match, we get an extra 8 here. God, mental math is going to be my downfall. I think 14. Yep. And then we have 14 instances and so forth. And so the nice way we can do this, and don't get scared when I say this, this is basically dynamic programming, which is a lot scarier than it sounds. But basically what we're going to do is we're going to have a little variable for how many cards we have. So if I say cards is equal to this, and we have 1 card of each to start, and we're going to make as many, or we're going to make this list as big as how many cards we have. All right, so now what we're going to do is, first of all, we want to be able to know which card we're on. So we're going to add a enumerate here. And I'll just name it C for card. Now, what we can do is for I in range, num matches. So what we're going to do here is, let's say I'm on card 4. If I get 2 extra matches, I should go over cards at whatever card I'm at, so 4, plus I, some variable that I'm looping over, plus 1 because this is indexed by 0. So for example, if I have 2 matches, I want to update cards 5 and 6 indexes. So I have to add 1, and then I'll add the 0 for the first one, and then add 1 for the second one. So I'll do this, and what I'll want to do is I'll want to add however many cards I currently have at the position I'm at. So let me explain this a little bit more just because I think it's a little bit confusing. If I'm at position 4, so C is equal to 4, and then I have num matches is equal to 2. Like I matched 2 more things. What I want to do is I want cards at 5 to increment by however many cards I currently have. And I also want to do this for cards at 6 because I have these 2 matches here. So first of all, this we already have updated. This is this right here, whatever C is, because that's the current line that we're on. And then also, since we're doing this loop and in range num matches, this will give us a 0 and it'll give us a 1 and it'll stop right before it hits 2. So we add 1 to it so that we're getting that. If we didn't add it, we would increment cards 4 and cards 5, and that's a problem. So with all of this out of the way, if I go ahead and now for part 2, if we look at what they actually want, how many cards do you end up with? This we can easily get by doing sum of cards. And so if I go ahead and try this in my test case, I get 30. If you see here, we have 30 scratch cards. And then here, if I run it on my input, I get 104 and that ends with 665. And that's what I have here. So yeah, this day was a nice little soft introduction, I think, into dynamic programming. But yeah, overall, I think it was a fairly short day. So let me know if you have any questions. I think this might be a little bit of a pain to debug, but yeah, it's a fun day. Good luck.